In this problem, we're told that 3 randomly selected households are surveyed as a pilot project for a larger survey to be conducted later. The numbers of people in the households are 1, 4, and 7, and we consider that to be a population. We're going to take samples of size n equals 2. Those are going to be randomly selected with replacement from the population of 1, 4, and 7. So we can easily list all the possible samples since we have such a small population. And they give you the list of the 9 different samples. So we've got 1, 1, 1, 4, etc. First, we want to construct a probability distribution table that describes the sampling distribution of the proportion of even numbers when samples of size n equals 2 are randomly selected. So in order to do this, I'm going to look at all the possible pairings of numbers. What I like to do with this, and I could just use this list that we have here, 1, 1, 4, etc. What I personally like to do is just make a little table, and my population is 1, 4, and 7. And since we only have samples of size 2, then I just list 1, 4, and 7, and now I have spaces for all the possible pairings. So instead of being an addition table, you probably remember that from when you were a kid, and 1 plus 1 is 2, and 1 plus 4 is 5, and all of that. That's not what we're looking to do here, but it's kind of the same principle. Here, now we're finding what is the proportion of even numbers. So if we look at the sample 1, 1, out of those 2 numbers, what proportion of them are even? They're both odd, so 0 out of 0 out of 2 of them are even. Then we look at the sample 1, 4. Out of that sample, 1 out of the 2 numbers is even, so that would be 1/2. 1 and 7, neither of them are even. 1 and 4, half of them are even. 4 and 4, now we have 2 out of 2, which is 1. And then 4, 7 is going to be 1/2. 1, 7 is 0. 4, 7 is half. And 7, 7 is 0. So I've got all my possible pairings, and I found the proportion of the numbers in each sample that are even. So now I can construct my probability distribution table. I'm going to do that over here. So I have my proportions, and then I have the associated probability. So, first of all, I've got the number 0. That shows up 4 times in my list. In your homework, they always like you to start with the smallest number and work your way up. Mathematically, it really isn't absolutely necessary. But it's not a bad idea just to make sense of everything. And 4 out of the 9, so we have 1, 2, 3, 4 out of the 9 different proportions that we calculated here. So it's always going to be out of 9. This one is 4 out of 9. Then we have 1/2 is the next value, and 4 out of 9 again are 1/2. So we see those 1, 2, 3, 4. And then there's one case where both numbers are even, so that's going to be 1 out of 9. And I double check this, 4/9 plus 4/9 plus 1/9 adds up to 9/9, which is 100% of all the possibilities. So we know that probabilities are supposed to add up to 1, and that worked out. So that's my probability distribution table. Now in part 2, they ask, does the mean of the sample proportions target the value of the population proportion? So we have two values that we're looking for here. We want to know what is the mean of the sample proportions and what is the value of the population proportion. So let's start with the mean of the sample proportions, and that's the mean that we calculate with this information, our probability distribution table that we just computed in part 1. I can calculate the mean of the proportions pretty easily by hand by simply taking each individual value times its probability. So I have 0 times 4 over 9, 1/2 times 4 over 9, and 1 times 1 over 9. And I take each of those products and I add them up, and that gives me the mean of the sample proportions. So 0 times 4 over 9 is just 0. Half of 4/9 is 2 over 9. And 1 times 1 over 9 is just 1 over 9. That all adds up to 3/9, which is 1/3. So that's how I would do that by hand. My alternative is to put the proportions into list 1, the probabilities into list 2, and calculate one variable stats, and you'll have to tell the calculator you want the list to be L1 and the frequency list to be L2. So it's going to be one variable stats L1, L2, and when you put that in, you're going to find that X bar equals 1/3, or 0.333. So that's how you would use the calculator to do that. So we have the mean of the sample proportions. Now I want to know what is the population proportion. And that's a lot easier to calculate. We have the numbers 1, 4, and 7. That's our population. What proportion of those numbers are even numbers? And it's the only one that's even is 4 out of the 3 numbers, so it's 1 over 3. So now I can see that the mean of the sample proportions turns out to be exactly the same as the population proportion. And we expect that when we're working with proportions, because we know that the mean of the sample proportions always targets the value of the population proportion. And that's why the sample proportion makes a good estimator of the population proportion. So keep in mind that the sample mean, sample proportion, and variance are all values that target the value of their respective parameters, and so they all make good estimators of their parameters. And if we're talking about the median, the range, or the standard deviation, we're going to say it does not target the value of the population, whatever the parameter is, and they do not make good estimators of that parameter. So when you see that they're asking about proportion, you know automatically that we're going to say, yes, it's a good estimator. It's really asking the same thing as when it says, does the mean target the value of the population proportion? So the answers to 2 and 3, they're either going to be both yes or both no, and it really just depends on what particular statistic that you're looking at. So that's how you would do that problem.